Have you ever wondered why the sky is blue? Why is it not green, purple, or any other color? The answer lies in the way that sunlight interacts with the molecules of air in the atmosphere. Sunlight, or white light, is made up of many different colors of light, each with a different wavelength and energy. When sunlight reaches the Earth, some of it is absorbed or reflected by clouds, dust, and water vapor, but most of it passes through the atmosphere. However, as it passes through, it is scattered by the molecules of air, especially nitrogen and oxygen, which make up about 99% of the atmosphere. The scattering of light is a process in which light waves change direction when they encounter an obstacle, such as a particle or a molecule. The amount of scattering depends on the wavelength of the light and the size of the obstacle. In general, shorter wavelengths of light are scattered more than longer wavelengths, and smaller obstacles scatter light more than larger ones. This means that blue light, which has a shorter wavelength than other colors, is scattered more by the molecules of air than any other color. This is why the sky appears blue to our eyes. The scattering of light by the molecules of air is called Rayleigh scattering, named after the British physicist Lord Rayleigh, who first explained it in the 19th century. Rayleigh scattering is a type of elastic scattering, which means that the energy and frequency of the light waves do not change after scattering. However, the direction and polarization of the light waves do change, and this affects the color of the sky. Rayleigh scattering is more effective for shorter wavelengths of light, such as blue and violet, than for longer wavelengths, such as red and orange. This is because the amount of scattering is inversely proportional to the fourth power of the wavelength. This means that blue light is scattered about 16 times more than red light by the same molecule. However, we do not see the sky as violet, even though violet light is scattered more than blue light, because our eyes are more sensitive to blue light than to violet light. Also, there is less violet light in sunlight than blue light, because the sun emits more blue light than violet light. The color of the sky is not always the same. It changes depending on the position of the sun, the weather, and the location on the Earth. For example, when the sun is low on the horizon, such as at sunrise or sunset, the sunlight has to travel through more air to reach our eyes. This means that more of the longer wavelengths of light, such as red and orange, are scattered by the air molecules, leaving less of them in the direct sunlight. This makes the sun appear redder and the sky around it appear more orange or yellow. On the other hand, when the sun is high in the sky, such as at noon, the sunlight has to travel through less air to reach our eyes. This means that less of the longer wavelengths of light are scattered, leaving more of them in the direct sunlight. This makes the sun appear whiter and the sky around it appear more blue. The color of the sky also depends on the weather and the location on the Earth. For example, when there are clouds in the sky, they reflect and scatter some of the sunlight, making the sky appear lighter or darker, depending on the type and thickness of the clouds. When there are dust, smoke, or pollution in the air, they also scatter some of the sunlight, making the sky appear more hazy or gray. When there are water droplets or ice crystals in the air, such as in rainbows or halos, they refract and reflect some of the sunlight, making the sky appear more colorful or bright. The color of the sky also varies with the latitude and altitude of the location on the Earth. For example, at higher latitudes, such as near the poles, the sun is lower in the sky for most of the day, making the sky appear more reddish or orange. At higher altitudes, such as on mountains, the air is thinner and cleaner, making the sky appear more blue or purple. The color of the sky is a result of the scattering of sunlight by the molecules of air in the atmosphere. The amount of scattering depends on the wavelength of the light and the size of the molecule. Blue light, which has a shorter wavelength than other colors, is scattered more by the molecules of air than any other color. This is why the sky appears blue to our eyes. However, the color of the sky is not always the same. It changes depending on the position of the sun, the weather, and the location on the Earth. Sometimes, the sky can appear red, orange, yellow, green, purple, or even black, depending on the conditions. The color of the sky is a beautiful and fascinating phenomenon that reveals the nature of light and the composition of the atmosphere.